Pick up a king crab and flip it over. Its abdomen is lopsided, twisted to one side, like it was meant to curl into a spiral shell, because it was. King crabs descended from hermit crab. Their bodies still carry the evidence of a life they abandoned millions of years ago. But king crabs are not the only crustaceans faking it. Porcelain crabs, hairy stone crabs, and even coconut crabs all evolved that same flat crab shape from completely different ancestors. Evolution has invented the crab at least 5 separate times, and then uninvented it 7 more. The scientific word for this is carcinization. It was coined over a century ago by the evolutionary biologist L.A. Borradaile, and it describes one of the strangest patterns in the entire history of life on Earth. Unrelated crustacean lineages separated by hundreds of millions of years keep converging on the same body plan: a wide, flat carapace with a short, tucked abdomen folded underneath, strong walking legs, an armored shell, and that distinctive sideways gait. The crab shape, assembled again and again from ancestors that looked nothing like crabs. In 1992, a team led by Cunningham published molecular evidence in Nature confirming what anatomists had long suspected. King crabs belong inside the hermit crab family tree. They are not true crabs at all. They are hermit crabs that grew out of their shells. The evidence is written on their bodies. True crabs have 4 pairs of visible walking legs. King crabs have 3, with the 4th pair reduced and hidden under the carapace, the same arrangement found in hermit crabs. And that twisted abdomen, the one that looks broken or deformed when you flip a king crab over, is a leftover from ancestors who needed an asymmetrical body to coil inside snail shells. According to the Cunningham study, the transformation from shell-dwelling hermit crab to free-living king crab took somewhere between 13 and 25 million years. 13 million years to stop needing a borrowed shell and grow your own armor instead. Porcelain crabs did something similar from a completely different starting point. They descended from squat lobsters, small, elongated crustaceans that look more like flattened lobsters than crabs. Over millions of years, porcelain crabs shortened their bodies, widened their carapaces, and folded their abdomens underneath, producing a body that, from the outside, is almost indistinguishable from a true crab. You could set a porcelain crab next to a shore crab, and most people would never notice the difference. But genetically, a porcelain crab is closer to a squat lobster than it is to the crab sitting right next to it. And you can tell by counting legs. True crabs walk on 4 pairs. Porcelain crabs, like king crabs, only use 3. That 4th pair is shrunken and tucked away, a giveaway that their ancestry is something else entirely. Then there is the hairy stone crab, Lomas hirta, a small brown hair-covered crustacean found along the rocky coasts of southern Australia. It is roughly the size of a bottle cap, it barely moves, and it represents an entirely separate carcinization event within the Anomura, the broader group that includes hermit crabs and squat lobsters. The hairy stone crab walked the same evolutionary path as king crabs and porcelain crabs, arriving at the same crab-like body from yet another direction. 3 different starting points, 3 different timelines, 1 destination. So you have 3 separate lineages within the Anomura alone: king crabs, porcelain crabs, and hairy stone crabs, all independently evolving into crabs. Add in the true crabs, the Brachyura, which underwent their own ancient carcinization event, and the total reaches at least 5 independent origins of the crab body plan. According to the 2021 BioEssays paper by Wolfe, Luque, and Bracken-Grissom, the common ancestor of all these groups was probably not crab-shaped at all. The crab form was invented fresh each time. But that is only half the puzzle, because evolution did not just keep making crabs, it also kept unmaking them. According to that same 2021 paper, at least 7 lineages have undergone decarcinization, the evolutionary reversal of the crab body plan. These are animals that were crabs, or at least crab-shaped, and then evolved back toward a more elongated form. The frog crabs, Rhininoidea, are true crabs that stretched their bodies back out into something torpedo-shaped, probably because they burrow backward into soft seafloor sediment, and a narrow body works better for digging. Their carapace is longer than it is wide. Their abdomen is partially exposed. They swim backward by flicking their tails. They look almost nothing like a typical crab, even though they are one. The coconut crab is another strange case. It is the largest land-dwelling arthropod on the planet, weighing up to 4 kilograms, strong enough to crack open coconuts with its claws. It descended from hermit crabs and went through partial carcinization, developing a hardened, crab-like body as an adult. But young coconut crabs still carry snail shells for protection, the way their hermit crab ancestors did. As they grow, they abandon the shell and harden their abdomens with chitin and calcium carbonate instead. One animal, carrying the entire evolutionary transition in its life cycle. You can watch a coconut crab grow up and see carcinization happen in real time, compressed from millions of years into months. Why does evolution keep landing on this shape? The honest answer is that nobody fully knows. The leading theory involves the physics of life on the ocean floor. A wide flat body can squeeze into tight crevices between rocks. A tucked abdomen protects the soft parts from predators. A hard, domed carapace acts as armor. Strong laterally moving legs provide stability on uneven surfaces and the ability to scuttle sideways without turning, keeping eyes and claws pointed at a threat while retreating. Every one of those traits is useful on a rocky seabed, and the combination of all of them produces the crab. But this explanation has limits. It does not explain why the crab shape evolved in deep water, in freshwater, on land, and in wildly different habitats across every ocean. It does not explain why some lineages that seem perfectly suited for the crab lifestyle abandoned it. And it does not explain why the crab shape emerged 5 times, but other seemingly useful body plans, like the lobster shape, did not keep popping up independently in the same way. If you're finding this interesting, subscribe. There are more deep dives into animal evolution on this channel every week. The Wolfe, Luque, and Bracken-Grissom paper suggests that carcinization might be less about environmental pressure and more about developmental constraints. In other words, something about crustacean genetics might make the crab shape easier to evolve than other shapes. Certain body plans might sit at the bottom of a developmental valley, a default configuration that the genetic machinery falls into more readily than alternatives. If that is true, then carcinization is not just natural selection picking the best shape for the job. It is the architecture of crustacean DNA nudging evolution toward the same solution over and over. The way water flowing downhill finds the same low points regardless of where it starts. This idea is harder to test than the environmental explanation, but it would explain something the environmental theory cannot. Why crabs specifically? Lots of body plans work well on a rocky seabed. Plenty of marine animals are flat. Plenty tuck their soft parts away. But only crustaceans keep converging on this one particular arrangement of traits. If the crab form is partly an artifact of how crustacean development works, a shape that crustacean embryos can reach more easily than other shapes, then the pattern makes more sense. It is not that being a crab is the best possible body plan. It is that being a crab is the easiest body plan for a crustacean to stumble into. And yet the fact that at least 7 lineages walked away from it suggests the crab shape is not inevitable. It is not a trap. Animals that became crabs can stop being crabs if the pressure changes. For crabs went back to burrowing. Some hermit crabs remained hermit crabs for over 150 million years, never bothering to carcinize at all. The crab is a recurring answer, not a permanent one. There is a word biologists use for this broader phenomenon: convergent evolution. Dolphins and sharks independently arrived at the same torpedo shape. Bats and birds independently arrived at powered flight. Eyes evolved independently dozens of times across the animal kingdom. But carcinization might be the most dramatic example of convergent evolution anywhere in biology, because it happened so many times in such closely related groups, and then reversed itself almost as often. Evolution keeps making crabs, then it keeps changing its mind. The fossil record stretches this story back roughly 250 million years. The crab-like body plan has been appearing and disappearing across that entire span. 250 million years of crustacean evolution, and the crab shape keeps surfacing like a pattern the system cannot shake. Biologists have mapped carcinization events across both Brachyura and Anomura, and the pattern spans almost the entire Mesozoic and Cenozoic. From the age of dinosaurs to right now, crustaceans have been independently building crabs. Somewhere in the intertidal zone right now, a porcelain crab is wedged under a rock, looking identical to the true crab next to it. One descends from squat lobsters, the other from an ancient Brachyuran lineage. They share no recent common ancestor. They arrived at the same shape through completely different evolutionary paths, separated by hundreds of millions of years. And neither of them knows that at least 5 other lineages have done the same thing, or that 7 more tried it and quit. If you want more stories like this, they are all on the channel.